Hi, it's Mr. Anderson, and today I'm going to be talking about voltage, current, and resistance. All of these things are found in electric circuits. It's hard to see electricity move, and so lots of times we don't have a gut instinct for what's really going on. And so I always like to start with an analogy. The analogy here is going to be the analogy of water. And so if we have a bunch of water at the top of a water tower, it has potential energy. And potential energy in electricity is going to be called voltage, and we measure that in volts. As that water flows down to a toilet or a sink, the current, and the symbol for that is I, the current is going to be how much of that water is actually flowing. And so the water is going to flow down and eventually through the sinks in the toilet. It's hopefully going to be cleaned and then eventually pumped back up to the top of that water tower again. And so what's resistance? We call that R. Resistance is simply anything that resists the flow of that electricity. And so anything like smaller pipes or maybe clogging inside the pipes that slow down the passage of the water is going to offer resistance. Likewise, anything in a wire or anything that slows down electricity is going to offer resistance. And so voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. And each of those terms comes from a famous scientist that figured some things out about electricity. Now, today I'm going to use what's called the circuit construction kit. If you want to play around with this, you could go to this website. It's called phet.colorado.edu, and they put together a wonderful simulation that shows you how electricity actually works. And so it's a circuit construction kit. The one that I'm using is a DC, that means direct current construction kit. And so what you can do is you can add a battery. So let's add a battery. And if you control click on it or right click on it, you can actually show the value. And so this is a 9-volt battery. So that means it has that much potential energy. And so the batteries that you put in a fire detector would be an example of a 9-volt. Let's add a wire to that and another wire. And let's measure the current that flows through it. And so I'm going to put an ammeter out here. Let me grab that. And this is going to measure the amps, which is going to be the current that flows through it. Let's also grab another wire, and let's kind of make this a complete circuit. So if I grab a wire here, another wire here, and then we connect it back up. Okay, so if we add a wire over here as well. Now, if you know anything about electricity, you know that something bad is about to happen. I'm about to short this battery. So what happens to a battery when it's shorted out? Well, you can see that the electrons are just cruising around. You see the ammeter is it's pegged all the way to the top. It also says that it's reduced the animation to less than 1% of its normal speed. And so in the lab, that's bad because you'll get sparks and you also could explode your battery. So let's not do that. I'm going to split this junction right here. And actually, let me split it right here. So that's bad, or that's not a healthy circuit. And so now let's add the third thing. So again, what we have is we have voltage, that's the potential energy. We have current, that's the flow of the electrons. But now let's add a resistor here. So if we add a resistor to our circuit, and then connect it up and let it run, then we have a healthier looking circuit. And so what we now have is potential energy that's pushing the electrons in this direction. It's going through an ammeter, which is measuring the amps as it moves through it. And now we have a resistor, and that's something that's slowing down the passage of those electrons. And let's actually show that value. Okay, so what do we have? Let's get back to our terms again. We've got voltage, or V, and we can see that that's a 9-volt battery. We have amperage, and so that's going to be current, and we use I to explain what current is, or that's the symbol for current. We measure that in amps. And then the last thing we have is resistance, and resistance is going to be measured in ohms. And so we can actually look at these values, and you should be able to figure out what's called Ohm's law. So we have 9 volts, we have 10 ohms of resistance, and we have 9 amps. And so if you take 9 equals 10, sorry about the bad writing, times 0.9. In other words, we could start just with the numbers itself, and so Ohm's law is simply this: V equals I times R. Whoa, that's an ugly looking R. So V equals I times R. In other words, the voltage equals the current times the resistance. And so what should happen if we increase the voltage? Well, if we increase the voltage and the resistance is set, so it's not going to change, if we increase the voltage, what should happen to the current? Well, let's try it. So if I do that, if I increase the voltage, excuse me, so let's change the voltage. Let's now change it to a higher value. What's going to happen to the amps or the current? The current is going to increase. The resistance stays the same, and so as I increase the voltage, what's going to happen to the current? The current's going to increase. And the cool thing about this animation is, watch, if we increase the voltage even yet, it shows the electrons, or it tries to represent the electrons in their speed. And so the more volts that we add to our battery, the more current we get moving through it. Now, likewise, what happens if we change the amount of resistance? So now let's change the resistance. So it's a 10 ohms. Let's increase it. Let's say we increase it. Let's say we make it 51 ohms. What happens to it? Well, as we increase the resistance, then the current is going to decrease. And so there's an inverse relationship between the resistance and the current, and then there's a direct relationship between the voltage and the current. And so that's going to be simple. That's simply going to be Ohm's law. And so you can solve problems. In other words, if I were to close this up, let's close this up, not show you what it is. If I didn't know what the voltage was, but I knew that the current was 0.94 amps and I knew that the resistance was 51.25 ohms, we should be able to figure out the voltage. And so in a simple circuit, you can figure out based on current, based on resistance and volt, you can figure out one of the other ones. The best way that I remember this, and so you may use a different kind of a mnemonic to remember this, is I have this pyramid where I have voltage at the top, I have current on one side and resistance on the other, and so all I do is simply use my hand and I cover up the one that I want to find. And so let's say my unknown is voltage. I could simply cover up the V, and that's going to be the current times the resistance. And so if I don't know the voltage, so if I cover that up, voltage is simply going to be the current times the resistance. If I don't know the current, so let's cover that up. Let's say I don't know the current. Current is going to be the voltage divided by the resistance. And likewise, if I don't know the resistance, if I cover that up, resistance is going to be the voltage divided by the current. And so this whole thing is called Ohm's law. And this is bad writing. Not too good at the mouse. So this would be Ohm's law, and it just shows us the relationship between voltage, current, and resistance. And all of these are named after famous scientists that worked on electricity. This would be Volta, so the volts come from volta. This is the resistance, and so this is ohms, and then current is amp. Ampere is his name. And so that's Ohm's law, and the easiest way to figure out how each of these things work is to actually use the circuit construction kit. You can also use things like this. We can use a voltmeter, so we could put a voltmeter right here, and you can actually put the voltmeter in different places and it'll measure the voltage, and so that voltage would be 48.12. And so you can use an ammeter, and then let me get rid of that for a second. If you really want to have fun, then you add something called a light bulb. And so if we add a light bulb to this, again, we have to have electricity flow in one direction and in the other. We can actually generate light. And so if I change the resistance, so let's change the resistance. So let's get a variable resistor. I can decrease the amount of resistance and we get greater current. So we have electrons that are flowing at a greater rate, and we also have more light and we have more heat. And that's a simple circuit. I'll talk more about what is a parallel circuit, what is a series circuit a little bit later, but I hope that's a great start.